Hello guys, welcome to our channel Online Education. We are learn about physics first chapter force. What is a force? Have you ever picked a heavy stone? How does a paper body throw a newspaper? Have you ever wondered about this action? Action like stretching a rubber band, pulling a rickshaw, rowing a boat, etc. are some more examples where are you effort help to change the position or shape of the object. Such action like picking, squeezing, twisting, stretching, lowering and lifting, etc. cause a change in the state of an object. Now let us try to group this task as a pull or a push. Force is a push or pull which can which can go state or motion 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 of an object. Types of force: contact force and force at a distance. Field forces. Contact force and force at a distance. Field force. Observe the following figure. Why does the toothpaste come out when we press the tube? Why does the needle of a magnetic compass move when we place a bar magnet near it? Have you observed the difference between the force you applied on the tube and the force applied by a magnet on the needle of compass? You can see in picture. You observe that there is direct physical contact or interaction between your hand and the tube. Force which result when there is a direct physical contact between two interacting objects is known as a contact force. Observing the magnetic force. Take a swing needle, rub it with a bar magnet several times, always moving the magnet in the same direction. Does the needle get magnetized? You may find that the needle always acts like a magnet. With the help of a magnetic compass, you can identify the north and south pole of the needle. Pin a red color cocked ball to south pole and white ball to north pole of the needle, then drop it in a ball of a water. It floats. You can see in picture. Needle in such a way that unlike ends, white ball of first needle and red ball to second needle face each other. Now observe what happened this time. How do they push or pull each other? This action of push or pull arises due to a magnetic force. Observing electrostatic force. Take a balloon, inflate it a tie of the open end. Now cut a paper into small pieces and place them on the floor. Rub the balloon with a paper and bring the balloon near the paper. Pieces of paper. What happens now are the bits of paper pulled toward the balloon. Figure picture. Why does the balloon or attract the pieces of paper? Try to use paper and salt in the place of pieces of paper. What do you observe? The force exerted by a charged body on another charged body is known as electrostatic force. Gravitational force. If an object is thrown upward, there exists a force which pulls it down toward the earth. Because of this, it falls down to the ground. We call this force as a gravitational force. Visualizing magnetic field. You can see that in a small space around the magnet iron filings set themselves in a pattern because they are affected by the magnetic force of the field created by the bar magnet. The pattern represents the magnetic field. The space around the magnet where its influence can be detected is called the magnetic field. Contact force. Muscular force. Do you know from where the force comes? The force which we exert by using our body muscles is known as muscular force. Observing the changes in any muscles while working. Take a dumbbell and lift it in different way. Observe while doing this exercise. Which muscles is going to be shortened? Ask your friend to do the same and observe the movement of their muscles. The term muscles refer to multiple bundle of muscles cell. Held together muscles are normal arranged in such a way that as one group of muscles contract or shortens, another group relax or expand. From example, if you throw a ball, the muscles in the chest and front side of the shoulder lengthen to pull the arm forward, while and the muscles in the back and rear of the shoulder undergo contraction to slow down the motion. Second, force of friction. When you roll a ball on a level ground, it invariably stop after some time. If you stop pendingly your bicycle on a level road, you observe that its speed decreasing gradually. What is a friction? Friction is the resistance to the movement of a body over the surface of another. Normal force. Place your science book on the table. Is it in a state of rest? Is there any force acting on that book? Imagine that the table has disappeared suddenly by magic. What will happen? Then the book will fall down due to gravitational pull of the earth. Even when a book is lying on the table, the gravity pulls the book down all the time, but it does not fall down because it is supported by the table. Therefore, there exists a force which supports the book against gravity by pushing it upward. Look at the picture. A direction which is perpendicular to the plane of a surface is said to be normal. The force a solid surface exerts on any object in the normal direction is called the normal force. Tension. As shown in the picture, a stone is suspended with the help of a string and it's free and it's tied to the ceiling. We know that the stone would fall down due to gravitational pull weight of the earth if the steering is broken. For a stone tied to the steering, gravity pull down the stone all the time, but it does not fall down because it is supported by the string. Thus, there exists a force which supports the stone against gravity by pulling itward. You can see the upward has T. T was a T was a tension. You can see downward has a W. W was a weight. It is called tension, which always pull the body along. The string tension is a contact force. When you try to stretch a rope or a string, the tightness of rope or string is called tension. Lab activity. To find the limiting force that can be borne by a string. Material used. Spring balance weight. Light string are of 10 centimeter length and of equal thickness. Weight hanger. You can see in the picture. Procedure. Arrange the system as shown in picture, but some small weight like 50 grams on the weight hanger and not the reading of the spring balance. Now add some more weight to the hanger and not the reading of spring balance. Do the same till the string is broken. Note the reading of the balance in the following table. When the string is broken, find out the limiting force of different types of steering and mention the values. Net force. In reality, many forces can act simultaneously on a body. For example, there exist two forces on an object placed on a horizontal floor. On is gravitational force vertically down and other is normal force vertical up. Do you observe any changes in the state of rest of that object because of this force? Obviously, your answer is no. In this case, two forces acting on the object are equal and opposite in direction. Effect of net force acting on a table. Try to push a heavy wooden table. This is shown in first picture. Is it hard to push? Ask your friend to help you in pushing the table in the same direction as shown in the picture number 2. Do you find it easy to move the table now? You may notice that it is easy to push the table when you take the help of your friend. The force applied by your friend added to the force exerted by you result in both forces being applied on the table in the same direction. The total force applied by both of you made it easy to move the table. Now ask your friend to push the table from the opposite side as shown in picture number 3. Does it move? If it moves, then in which direction does it move? When you and your friend push the table from opposite side, the table does not move if the of you apply force with equal magnitude. Let us assume that one of you exert a larger force, what will happen? Why? All forces have both magnitude and direction, while adding force or direction of force have to be taken into account. When forces act on a body along a straight line and they are in the same direction, the net force is taken as the sum of all forces acting on the body. To add forces, convention must be used. Example F1, example F2. As shown in the above picture, the force F1 directed toward right called be taken as positive, and the force F2 acting toward left called be taken as negative. Let the force F1 and F2. F1, you can see in third picture, F1 is green t-shirt, F2 is pink shirt. F1 and F2 act on the table in opposite direction as shown in the figure, and F1 and F2. Then F1 net is equal to F1 plus minus F2 is equal to F1 minus F2. When the force on a body in a straight line are in opposite direction, the net force is equal to difference between the two forces. The object at rest moves in the direction of the net force acting on it. Effect of stretched rubber band on finger. Take a rubber band, stretch it using your finger. When you stretch the rubber band, it exerts force on your finger and you feel the force of pull on your finger. What happens if you add one more similar rubber band around your finger and stretch both together to the same length? Do you feel the combination of two bands exert a larger force than that of on? Increase the number of rubber band around your finger and observe the force exerted on your finger by the rubber band. You can see in the picture there has only one rubber band, there has so many bands. Let us say the force exerted by one rubber band is F units and the force exerted by the second rubber band is also F units. Then what will be the net force of two rubber bands? We can express it as F net. F plus F is equal to 2F units. The unit of force in SI system in Newton. And what is the net force acting on your finger when the 3, 4, etc. rubber band are used? How to calculate net force from free body diagram? The diagram showing all the force acting on an object at a particular instant is called free body diagram. It is denoted as FBD. Example, let a car be moving with a non-uniform speed along a road. What are the force acting on the car? What is the net force acting along the vertical direction? What is the net force acting along horizontal direction? Draw all the relevant force acting on a body. We call it a free body diagram, FBD. Choose a coordinate system with x minus axis and y minus axis as shown in picture. Sign- Signature convention is to be taken along x and y axis direction at force algebraically with signature convention along x and y axis separately. Then those values give net force along x and y direction respectively. You can see in the picture was a solution. The force acting on the car are shown in the FBD free body diagram. They are force applied by the engine F, friction applied by the road F, normal force are N and N2, gravitational force Fg is equal to W, net force along x axis or direction F is equal to F minus F, net force along y-axis or direction F is equal to N1 plus N2 minus W. Effect of force on change of the state of motion an object and its direction. Place a football on the ground, the ball will remain in a state of rest unless someone kick the ball. Now kick the ball. You can see in picture what happened. Does the ball start moving? Kick the moving ball again in the same direction in picture. What will be the result? Place your hand or leg against the ball. Does the ball stop or does it change its direction? Not you observe. You can see in the picture foot, football was kicked. One man was kicked on the football. Football direction was changed. We can move the ball from its position of rest by applying a force on it. We can stop the moving ball and it back to rest by catching it. Giving few more examples where the state of motion of an object change due to the application of force. Effect of net force on direction of moving object. It a carom coin with the sticker. Ask your friend to do the same. Does the coin move in the same direction? In each case, if not, why? You can observe that in each case the direction of the coin change when you hit the coin with the sticker. Not only does the coin change its direction, but the sticker change its direction too. That might be the case of for that. From these observations, we can say that a net force stops a moving object, a making a stationary object or move, and a and also change the speed and direction of a moving object. Through a force can change the state of motion of an object. Effect of force on the shape of an object. In table 3, some situations are given in the first column showing how the force is applied on an object. Observe the shape of the object carefully before and after applying the force. Mark T for temporary change and mark P for permanent change in the second column. Change in effect of force with area of contact. Take a pencil, just push it rounded end on your palm. Now push from the other side of the pencil gently so that the shape end is on your palm. You different did you experience why? Identifying effect of force. Take you two trays will both the tray with lime powder or fine sand. Now take two rectangular bricks of equal mass and similar shape. Drop one brick vertically in one tray and the other brick horizontally. The secondly tray from certain height. What do you notice? Do both bricks sink to the same depth in lime powder? If not, why? You can observe in the picture A and B. You may notice that the brick standing vertical sinks deeper in lime powder than the brick standing horizontally. That's all for today. Thank you and मोर वीडियोस के लिए लाइक एंड सब्सक्राइब बेल आइकन दबाना ना भूलें अगर आप तक पूरे वीडियोस आप चाहते हैं तो।